Hello, my dear friends. Today I'm going to present you our paper with my doctoral student Theodor Daskalov about human-curated AI-assisted scenario design for game-based sustainability learning. My name is Prof.Nevyana, and I'll try to give you an idea about the main themes in our paper. The central idea is simple. We use artificial intelligence to expand and range of possible educational scenarios, but we do not give AI pedagogical authority. AI works before learners enter the activity, while human facilitators select, revise, and authorize everything that reaches and the learners. We implemented this approach in a cooperative tabletop simulation called Let Us Save the Forest, focused on water stress and the relationships among forest ecosystems, water bodies, and urban systems. The starting point of the study is water stress. We treat water stress not as a simple shortage of a resource, but as a systematic imbalance involving ecological, infrastructural, and governance interactions. This means that education should go beyond memorizing facts. Learners need to understand relationships, feedback loops, and consequences. Non-formal education, especially Scout-based learning, provides a useful environment because it emphasizes teamwork, responsibility, and action. Game-based simulation adds another important element. Learners can make decisions and immediately see how those decisions affect and interconnect the system. The research gap concerns the role assigned to AI. Many educational applications position AI as an instructional, adaptive, and automated component. Our studies takes a narrowed approach. AI is a design support mechanism operating before learner interaction. It generates candidate events and decisions, but these remain only candidate material until humans review and authorize them. This leads to three research questions: how to structure the workflow while preserving human authority, how to curate AI-generated elements, and what descriptive patterns of learning and engagement can be observed when the resulting simulation is implemented. The proposed framework has three stages. First, AI generates variability, possible ecological events, and possible response decisions. Second, human facilitators curate this material. They select, revise, or reject outputs according to pedagogical goals, age appropriateness, logical consistency, strategic balance, and compatibility with the game rules. Third, learners interact only with human-authorized scenarios. They make decisions, interpret feedback, and reflect on consequences. So the key principle is a separation of functions. AI expands the design space, but humans control educational meaning and pedagogical decisions. The pilot involved 24 adolescents between 12 and 16 years old, organized into 8 teams of 3 people. All participants were members of a Scout organization. The intervention consisted of 2 consecutive sessions, each organized around 8 gameplay rounds. The simulation represented 3 connected subsystems: water bodies, forest ecosystems, and urban areas. Each was represented on a scale from 1 to 10. The sustainability index was calculated as a mean of the three values. A key rule was the water stress threshold. When water bodies reach 3 or below, additional negative effects could occur unless a decision restored or retained water. This created cascading consequences and encouraged teams to think in terms of system interactions. AI was used only in preparatory phase. The paper reports the use of ChatGPT with GPT-5.4 thinking model across 6 prompting iterations. The process generated 32 event drafts and 24 decision drafts. After human review, 24 events and 16 decisions were retained. That corresponds to retention rates of 75% and 66.7%. Importantly, not everything generated by AI was accepted. Facilitators independently screened the material for relevance, logical consistency, age appropriateness, variability, strategic balance, comprehensibility, and compatibility with the simulation rules. They also edited the retained material. This is important because human curation was not simply a final check, it was an explicit stage of educational design. The descriptive results show higher final scores across all measured cognitive indicators. Understanding of water stress increased from 1 to 2.5. Understanding of role of forest ecosystems increased from 1 to 2.7. Sustainable decision making increased from 1 to 2.0. The behavioral indicators also increased. Participation rose from 2.0 to 4.0, initiative and collaboration from 3.0 to 5 to 4.5, and both ecological reasoning and decision justification from 2.0 to 4.0. These are descriptive pre-post differences. The study deliberately does not interpret them as evidence of an independent cause effect of AI. The main contribution is therefore procedural and conceptual. The study shows that AI can expand the pool of scenarios without becoming the instructional decision making. The observed learning and behavioral patterns suggest that the resulting simulation was workable as a collaborative learning environment. However, we should be careful about what these results mean. There was no control or comparison condition. The analytical unit was 8 teams and the same teams participated in both sessions. Therefore, practice and familiarity with the game may explain part of the observed environment. The study also relies on facilitator-rated measures, and formal inter-rater reliability could not be reconstructed from the available summary data. Finally, there was no long-term retention assessment. To conclude, the defining feature of the study is the separation between AI-generated variability, human pedagogical curation and authorization, and simulation-based learning. AI was useful for expanding the pool of possible scenarios, but all pedagogical decisions remained under human control. The descriptive results support the feasibility of the overall design, but they do not establish an independent causal effect of AI. Future research should use larger and more diverse samples, validated measurement instruments, direct comparisons between human-only and human-curated AI-assisted design, stronger reliability analysis, and long-term measures of learning retention. The broader message is that educational AI does not have to replace human judgment. It can be deliberately bounded to support human-designed learning. My dear friends, thank you very much for your attention. And now it's time for questions and answers. Thank you very much and have a very nice day.